Hello students, I am Dr. B.K. Singh, Professor of Civil Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. So, today we will be discussing a mixed design of M25 grade concrete by the method IS 10262 2019. So, that is the latest method of designing by IS code, because this code has been 10262 has been revised recently in 2019. So, we will be discussing this one in details. So, previous lectures we have discussed regarding this code book, and this particular lecture I will discuss the actual design of M25 grade concrete, and in this one we will be designing without mineral admixtures. Okay. So, these are the steps involved in any mixed design. So, suppose what are the different methods? So, stipulations for the proportioning. So, different type of data is required, what are the data required, that we are supposed to do it. Then once we have the data and samples from the field, then we go for the test. So, we have to perform certain test and we have to obtain the data from that. So, with the help of test data and stipulations, we will be able to design the values. So, third step is target strength for mixed proportioning. So, whatever the target is given, say I have told I want to design M25 grade concrete. So, M25 grade, because this is not a very homogeneous in nature and different steps is involved in concrete processing. So, we have to give certain margin, because quality control at each and every stage is not possible properly, or if the contractor is not of very good quality. So, you have to increase the mean target strength. So, that data is required. So, then we have a selection of water cement ratio. So, water cement ratio is very important parameter in design, because once you have a water, so if water content is there, that is responsible for your workability. Okay. And amount of cement is also required for the strength. So, water cement ratio determines the strength parameter. Okay. Then we have selection of water contents. What should be the total amount of water in 1 meter cube of concrete. Then proportion of volume of coarse aggregate and fine aggregate. Then mix calculation we have to do. So, let us move further here. So, in this particular lectures I will discuss from 1, 2, 3, 4, and next lecture I will discuss 5, 6, 7. Okay. So, here, so what is the stipulations given? We need a grade designation M25. So, type of cement. So, 43 grade ordinary Portland cement conforming to IS 269 2015. So, we have different grade of ordinary Portland cement like 33 grade, 43 grade, 53 grade, 53 grade sleeper class. So, all this specification has been given modified in IS 269 2015. So, earlier they are having the different code for different ordinary Portland cement. So, now they have combined all the properties in only one code IS 269 2015. So, this specification also you are supposed to check. So, whenever you are getting the cement from the field, we have to do the testing and satisfy the requirement of 43 grade ordinary Portland cement. Then we have maximum size of coarse aggregate, because you have a different size of coarse aggregate, 20 mm downside, 20 mm downside, 40 mm downside or 80 mm downside. So, here this particular requirement, field requirement is 20 mm and downside. So, this is the maximum size of aggregate. Okay. Then minimum amount of cement is also specified 300 kg per meter cube. So, you may gain the strength by controlling the water cement ratio with the lesser amount of cement also. So, even 220 kg also you may get, but for the durability requirement exposure condition minimum amount of cement is 300 kg per meter cube. So, that you have to also keep in mind. So, 300 kg is the minimum requirement. We have 5 exposure condition. So, one is mild exposure condition, moderate exposure condition, severe, very severe, extreme. So, even mild and moderate we need a 300 kg per meter cube of cement for the durability requirements. Okay. Next is maximum water cement ratio. So, this is also if you go to the IS 456 table number 5. So, based on durability requirement, okay, exposure condition. So, here in our case it is exposure condition is if you see the IS 456. So, maximum cement ratio for M25 here is for moderate condition. So, exposure condition you can say is our moderate exposure condition, and you have not increased the water cement ratio 50. Even say we are able to get the strength M25 with the help of water cement ratio of more than 50, but no, we have to restrict to 50, that is important. Then workability. So, workability is here 75 to 125 mm slump value. So, this is the requirement. Suppose you want to go for the pumping also. So, you have around 125 mm slump value, then our concrete may be pumpable also. So, workability criteria is also important here. Then we have exposure condition. So, exposure condition is moderate. So, bracket is given for reinforced concrete. So, for reinforced concrete concrete we have to consider the workability exposure condition, because you have two conditions, one is reinforced cement concrete, another is plain cement concrete. So, plain cement concrete amount of cement water cement ratio specification is different than reinforced cement concrete. So, this is given in table number 5 of IS 456. So, we have to refer the 456 also apart from referring the 1026 to 2019 code. Okay. Then we have degree of supervision. So, degree of supervision is also important. If degree of supervision is not good, then we have to increase the mean target strength. So, this part will also come into picture. So, that will be given here, and then we have type of aggregate. We have a different types of aggregate. So, here we are using crushed angular aggregates. So, this is the site specification, and we have to use the chemical admixture. So, that is a super normal type of super plasticizer is permitted here. So, based on this data we have to go for the mixed design. So, mixed for the doing the mixed design we have to get cement, coarse aggregate, fine aggregate, water and admixture. So, based on the test requirement you have to satisfy their quality also. Okay. And then we go test data. So, once we got the material from the lab, from the field, we have to go for the testing. Okay. So, what are the tests we have to do? Cement use. So, we have 40 grade ordinary Portland cement conforming to IS. Sorry, now this is not required. So, you can use previously I have discussed IS IS 369 269 2015 code. So, this specification has been transferred to 2015. So, this one sorry, this has been typographical mistakes. So, we are using 43 grade ordinary Portland cement conforming to IS 269 2050. Then we have tested. So, as you tested in laboratory, how much you have got? 3.14. So, sometimes 3.14 is the standard value, sometimes you may get little lesser also, because sometimes we are adding some property enhancing material like a fly ash, silica fume, metakaolin, up to 5% is permitted to enhance the properties of cement. Okay. So, that time if you are using the fly ash, so instead of 3.14, that value may go down also, because it may go to 3.12 also. So, nothing to be worried. So, a specific gravity of chemical admixtures, we are using super plasticizer conforming to IS 9103. So, this code also you are supposed to refer while you are thinking regarding designing any mix. So, a specific gravity coarse aggregate they got 2.799, coarse aggregate 10 mm downside is 2.789, combined specific gravity of aggregate. So, say 60% is 20 mm and 40% is 10 mm is 2.795. Then we have fine aggregate. So, fine aggregate specific gravity is 2.517. So, water absorption test also has been performed. So, after the performing water absorption, we got coarse aggregate is having 0.41%, 20 mm size, and 10 mm down size is 0.59%, fine aggregate is having 1.87%, aggregate impact value is 20.52%, combined flakiness and elongation index is 27.57%. If we are using designing for the road or other purpose, this is very important parameter. And sieve analysis result is coarse aggregate conforming to all in aggregate of table 2 of IS 383, and fine aggregate is of grading zone 2. So, you are supposed to refer the IS 383 and just confirm this data, means you have to do the practicals, experimentation, get this data, and then you go for the design. So, next step is target strength for mix proportioning. So, target, because suppose quality of contractor is depends on, because we design this, if you see this curve here, okay. So, our value is, it may be up to 5% value we can allow less than mean target, less than characteristic strength. Okay. So, achieve that, if quality of contractor is good, then this standard deviation may be low. If the contractor is not good, then that standard deviation will increase and you can get a flat curve like this. Okay. This curve will become flat in this person. So, depends on the quality of supervision, we have to adopt the standard deviation. Okay. So, this equation you have to follow, f dash c k mean target strength is given by f c k plus 1.65 into standard deviation. So, this 1.65 is for, this constant is for 95% confidence limit, means 95% of the sample will not fail. Will not fail. So, getting this standard deviation, at least you have to test this 30 samples, and one sample will consist of 3 samples. So, you have to, once you want to establish the standard deviation, we must get about 30 cubes of size 150 by 150 by 150 tested at different lot, and minimum value x value you have to consider. So, this is the new addition with respect to 2009 code. So, 2009 code, this expression was not there, which is the addition. So, this thing has been written here, what is the FCK dash, target average compressive strength at 28 days, FCK characteristic compressive strength at 28 days on cube of size 150 mm by 150 mm by 150 mm. S is a standard deviation, and x is factor based on grade of concrete. So, this value of a standard, if you do not have the data, initial data, because contractor you do not have their previous record. So, in that case what you have to do, you have to assume certain standard data, standard deviation. So, those standard deviation can be and x value, minimum value, if you see this previous one. So, minimum this much you have to increase x value. So, whatever may be the values. So, if your quality supervision good, then you can take this data. So, if have M10 to M15 grade, you have to take 5, M20 to M25 you have to take 5.5, M30 to M60 this is a standard concrete, M25 to M60 is a standard. So, suppose you want to design M30 to M60. So, minimum value you have to increase 6.5 to the characteristic strength, and M65 and above this category means high strength concrete. So, if you are using the high strength category, high strength concrete, then minimum you have to increase 8. Okay. So, this data has been given in table number 1 of IS 10262 2019. Okay. Then similarly, if you see the assumed standard deviation, because at initial stage we do not have the variation, how much variation is provided by the contractor. So, either you refer the IS 456, we are getting also the similar type of table. So, this is this table has been taken from IS 1026 to 2019. So, here once again if it is a M10 to M15, this value is 3.5, M20 to M25 you have to take the standard deviation 40 in Newton per mm square, M30 to M60 you have to take the value 5, and M65 onward you have to take 60, and this value if the quality of supervision is not good. So, that case we have to increase this value by plus 1 Newton per mm square, means we once again we are giving more tough things. Okay. So, that at least you will get the characteristic strength in the field. Okay. So, now you see the target strength for mixed proportioning. So, first what we have did, we got the different data, what are the types of aggregate you need, what are the field requirement. So, all these things, and then based of that we got the raw material for producing the concrete from the field, and those things we have tested for the in the laboratory on cement, coarse aggregate, fine aggregate, admixture and water, and if it is a mineral admixture, that also you have to test. But in this particular problem we are not using the mineral admixture. So, that will be taken in separate lecture. Okay. So, if you see here what I have taken M25 grade concrete. So, for M25 grade concrete what is the standard deviation? This is FCK into 1.65 is the constant, statical constant, and a standard deviation has been taken from the table number 2 here. So, what is here? This value is 4. So, this value has been taken here, just you multiply, you will get 31.60. Similarly, we have another equation F dash CK, mean target strength, equal to FCK plus X value. So, if you see the table number 1, FCK value for this one is 5.5 Newton per mm square. Okay. So, this data you have to take from this table, and here if you see it is coming 30.5. So, out of this whichever is having the maximum value, you have to take maximum value in this. So, maximum value you have to take. So, if you take the maximum value, so our mean target strength will be 31.60. So, if you see the approximate air content, so approximate air content, because whatever the means you adapt, so always there will be entrapped air. So, how much will be the air content? So, that will depend on the size of aggregate. So, whether it is a 10 mm downside aggregate or 20 mm downside aggregate or 40 mm downside of aggregate, amount of air will air content in the concrete will change. Okay. So, if you having the lower size of the aggregate, then air content will be more, entrapped air will be more, and if the size of the aggregate is more, then that case this value will reduce. So, our case, our aggregate maximum size of aggregate is how much? 20. So, 20 at least you can consider 1%. So, we can expect 1% 1% air in the inside the concrete. Okay. So, 1% we have to consider air content. So, that we have to take into consideration while we are doing the mix calculation. Then we have here selection of water cement ratio. So, water cement ratio is also very important parameter here in selection, because depends on the types of cement. So, we have 3 types of cement, 33 grade cement, for that this is the curve. For 43 grade cement or OPC or granulated grass OPC PPC sorry Portland Pozzolana cement or granulated ground blast furnace slag cement, you can use the curve number 2, and for curve number C is for 53 grade cement, 53 grade OPC you can use curve number 2. So, in our problem, our grade of cement is 43 grade. So, you have to refer this curve. So, what is our mean target strength? So, it is 31.60, that we have calculated from previous here. So, from 31.6 here, so just sorry. From here, say roughly it is coming like this, and if you go here and if you go at this place, what you will get? So, approximately you are getting about 0.48 water cement ratio. So, achieve that strength 31.60, how much we have to use? We have to use 0.48 water cement ratio. So, this is the requirement of 0.48 from a strength point of view, a strength point of view. So, now we have to consider the durability aspects. So, for durability requirement also you have to consider the water cement ratio. So, if your water cement ratio is more than 0.48, you will not be able to get this strength of 31.60. So, that is our mean target strength required. So, now we will see the requirement of durability condition also. So, out of this is very important. Okay. So, you see here another table you check here. So, this is the table we have taken from the IS 456-2000. So, we have 5 exposure conditions. So, exposure condition is mild, moderate, mild exposure condition, moderate exposure condition, severe, very severe and extreme. So, from field we have got the data that our concrete has to be used in moderate condition. Okay. So, definition of moderate is also be given in IS 456. So, that we are supposed to refer. Okay. So, once again our condition is not a plain concrete. For what purpose you have to use? You have to use reinforced concrete RCC work. Okay. You have to use for RCC work. Okay. So, here minimum amount of cement has been specified. Suppose our exposure condition is moderate. So, if you are using for plain concrete, so this part if you divide, this is for plain part. Okay. So, here what you are observing? So, 240 kg cement, with the help of 240 kg minimum cement you have to use. Minimum water cement ratio is, free water cement ratio is 0.6. So, free means water surface dry condition you have to use, water will be surface dry condition, and minimum grade of concrete you have to use M15. So, this is for requirement of PCC, but if you see the RCC, because that is susceptible to corrosion. Corrosion means it concrete still should be in passive condition. So, concrete has to maintain the alkalinity high. So, their alkalinity should be always should be more than 12.5. So, once their alkalinity is more than 12.5, corrosion will not take place, because reinforcement will be under passive condition. So, maintain that, but they have mentioned that minimum amount of cement you have to use 300 kg, and maximum free water cement ratio you have to use 0.50, and minimum grade of concrete you have to use M25. So, this is the limitation. This is the limitation. So, maximum water cement ratio is 0.5. So, you can go 0.43 also, 0.23 also, sorry 0.3 also. So, depends on the but grade, similarly grade of concrete is also limited, that you should not use less than M25 grade of concrete if your structure is in moderate exposure condition, moderate exposure condition. So, you are observing that our problem is M25 and maximum free water cement ratio is 0.50. So, here we in this table this water cement ratio. So, cement is nothing but, suppose instead of cement, suppose you are using some admixture. So, what are the admixture you can use? You can use the fly ash, ground granulated blast furnace slag. If you are using silica film, you are using. So, in that case what we have to calculate this water cement ratio. So, that is nothing but water cementitious ratio, you can say. This is nothing but free water plus cementitious ratio, you can say. So, that part you have to consider. Okay. So, that you have to use the standard pozzolanic material, or as what are the pozzolanic material you can use the silica film, you can use the blast fly ash, you can use the burnt rice husk ash. So, all these things can be used. So, if you are using that, so that case water cement ratio will be based on that ratio, but in our case we are using only 43 grade OPC, ordinary Portland cement. Okay. So, that case maximum water cement required is maximum free water cement required is 0.5. So, we have to check, one is from durability requirement. So, this table is considering the durability requirement. Okay. So, two criteria is there, one is cement, another is strength, and another is durability aspect. So, based on that, what we have got here, that we have got lower value than required for our this value. So, what is the value? Our value is 0.48 from water cement ratio is required for a strength point of view. Okay. So, that is lower than maximum value of 0.50 prescribed for from the table number 3 of IS 457. This is table number 5, sorry, table number 5 of maximum water cement ratio for moderate exposure condition. okay, moderate exposure condition. So, water cement ratio strength point 0.48 you have got, and here you have got 0.5. So, okay. So, how much water cement ratio we are going to adjust? 0.48. This is the thing. So, we will be continuing this another part of this mixed M25 in next lecture, lecture number 4, unit number 4, lecture number 4. Thank you.